Hi, I'm Jamie, and today I'll be joined by Boleslav, Vanessa, Andrea, and Aisha as we detail how we applied the ergonomic process to a ramp agent lifting and carrying luggage from the tarmac where planes dock to the baggage claim. For our project, we specifically targeted the lift from an unloading conveyor to the tram that transports luggage to baggage claim. Step 1. Characterize the existing problem. We helped characterize our issue by finding surveys from ramp agents. Over 70% of these workers reported low back pain due to their handling of heavy bags and suitcases. This is on top of neck, shoulder, and wrist pain. This survey indicates high amount of risk, especially in the lower back area. Trego Dugan Aviation presented a day in the life of a ramp agent and detailed the job task we have chosen to analyze. This one task is a major contributor to back, hand, and neck issues on the job. I'll now play the video. To further characterize the problem, we use statics to check our understanding of the issue. We assume postures that led to the lowest RAAAAAAAH scores for a 50th percentile male, and then we use the maximum mass of a business class suitcase of 32 kilograms from Kemp 2024. Our analysis found that the force on the L5S1 joint was 3,586.6 newtons. To recap our findings, we found that more than 50% of ramp agents reported pain in their lower back, their neck, or their hands. When looking at our visual example, we see a high force exertion and poor posture through grip on the bag. It is also assumed that this task is repeated for every bag on the plane, which is an example of high repetition. All of these are risk factors for WMSDs. Furthermore, through statics, we found that the ideal carrying posture, not even lifting for this scenario, exceeded the force of 3,400 newtons on the L5S1, as recommended by NIOSH. These findings characterize an existing problem. We must do further job analysis to fully quantify the issues with the task. I will now pass it off to Andrea to detail the job analysis that we performed.
Thanks, Jamie. Now let's look at our next job analysis method. We picked the RAAAAAAAH checklist as our first analysis method since it is inexpensive, cheap, and time efficient. The RAAAAAAAH checklist accounts for the entire body and certain task-related risk factors such as frequency per minute and load weight. It doesn't, however, account for individual capacities such as age, sex, and other variables. Since RAAAAAAAH only accounts for a moment of time rather than the entire task, we have to select a single posture to analyze. We chose the moment between grabbing the luggage off the conveyor belt, moving it to the luggage cart. While RAAAAAAAH can be subjective and scores varying, our interpretation of the pose landed the task with a high-risk label. Now, due to more certainty in the task risk, it is appropriate to do more detailed job analysis. I hand it off to Vanessa to talk about our next analysis method, the NIOSH lift equation.
Thank you, Andrea. For our second method, we chose the NIOSH lift equation, and this is because a lift is a part of the task that a ramp agent does when loading luggage. In order to perform the equation, we had to measure the different values of horizontal distance, vertical distance at the start and end of the motion sequence in order to get our value. Here are some clear pictures of Jamie replicating the task that a ramp agent does when loading luggage. To note something about our measurements. This suitcase that we used as reference was an empty suitcase, and ramp agents usually lift a much heavier suitcase. Here are the values that we recorded. These values, we calculated the value of each multiplier to calculate the weight limit. The equation, we found out that the recommended weight limit at the start would be 5.15 kilograms, and the recommended weight limit for the end being 3.32 kilos. And using the average luggage weights for full luggage on airplanes, we calculated the minimum and maximum possible lift indices. Since both start and end indices are greater than 3, it indicates a higher risk for the movement, indicating a need for potential improvement through controls. And so now I'll pass it off to Boleslav to talk about some potential controls that can be implemented to reduce risk.
Okay, let's talk about the controls we implemented. For our engineering control, we chose the Power Stow tail loader, which is a belt loader specifically designed with ergonomics in mind. As you can see in this video, through its high maneuverability, it is designed to make lifting and movement of baggage much less strenuous for the worker. One of the biggest problems we saw ramp agents face were the large movements they had to make to carry the baggage from the conveyor to what they were loading. The tail loader enables the worker to simply position the conveyor to deliver the luggage exactly on top of where they are loading, so that the carry distance would be shorter and their movements they need to take smaller. Our administrative control is worker training in proper lifting techniques with the aim of improving posture during said lifts. The nature of luggage handling can easily put workers in awkward postures due to the variation in sizes and weight of luggage. Poor lifting technique and posture is a surefire way of increasing WMSD risk, so it is important that the workers would be educated on how to ensure their safety. We are assuming the posture training would be done to teach the workers how to use the tail loader properly, and as such, we will be evaluating these controls in tandem, seeing how the new equipment and training work together to create a better work environment. Talking costs, there was no publicly available price for the tail loader, so we looked at prices of other belt loaders to get an estimate. Considering the Power Stow tail loader is a new specialty equipment, it would be on the more expensive side, ranging from $35,000 to $60,000 to purchase, and monthly rentals being $2,800 to $4,800, assuming a market standard 8% rental cost. For the administrative control, we calculated the opportunity cost of money the company would lose while workers were trained instead of actually on the field working. 2 4-hour paid shifts seemed sufficient to teach employees. Knowing that ramp agents on average make $17.27 an hour, we were able to conclude that it would cost the company $276.32 per trainee in the program. And now off to Aisha.
Thank you, Boleslav. We'll now move on to step 4 of the ergonomic process by evaluating the effectiveness of controls. The control we chose was implementing a Power Stow tail loader, which you can visibly see will reduce the amount of vertical distance a ramp agent has to travel. We used RAAAAAAAH to assess this posture and confirm the results of the NIOSH lift equation. Neck posture, leg posture, and arm and wrist all scored lower than our original score, which brought our RAAAAAAAH down from 9 to 5. RAAAAAAAAH confirms that the modified task reduces risk for a ramp agent. For NIOSH, we calculated start and end positions. Horizontal distance slightly decreased. As pointed out earlier, the difference in vertical distance was eliminated, and hence the multiplier that changed the most. Asymmetry, frequency, and coupling are all the same as the original. Here, we calculated our multipliers. As you can see, our recommended weight limit went up by about 2 kilograms. This is still a lot less than the average 20 kilogram suitcase, but the frequency and speed of these lifts is what creates the most risk for this task, and this is confirmed by the frequency multiplier being the lowest. The ramp agent is lifting a suitcase every 6 seconds, so this can be explained by the force-velocity relationship. The minimum lift index for the start position made it below 3, but the other values pose that this task is still a risk for ramp agents, and will need further controls to make it safe. Giving ramp agents more time to load and unload would probably be the safest option here because frequency for this task poses the most risk.
We will end with our summary. To summarize our results, we found that after implementation of the tail loader and worker training, we saw a significant reduction in the RAAAAAAAH score and to a lesser extent, a reduction in our NIOSH lift indexes. This means that our controls primarily improved the posture of our workers, but didn't do much to change the repetition of the task or the weight of the luggage. Due to this, the task still raises some risk concerns, but has definitely improved from its initial state. Our controls also integrate smoothly into the existing task and didn't seem to cause any problems in other areas. Finally, here are some references. Thank you very much for watching our presentation.